Welcome to the E-Academy. Today's episode is an introduction to the KNX building automation system, specifically a presentation of what SATEL can offer in this area. We will briefly discuss devices from the SATEL range that are designed to work within this system. But first, a few words of introduction. KNX is currently one of the most widely used systems in the world, and also the most universal intelligent building system. Within KNX, the most diverse smart building functions offered by various actuators, as well as sensing and measuring devices, can be combined. We can control and automate the operation of, for example, lighting, ventilation, heating and air conditioning, curtain drives or gates. In addition, the system is also referred to as a standard. This means that it is created not by one entity but by hundreds, with the guarantee that their products will work together. When properly programmed, of course. At the time of recording this episode, there are exactly 500 manufacturers affiliated to the KNX Association. Another important feature of KNX is its decentralization. This means that there is no single master controller, control panel, or hub controlling the operation of the entire installation. The individual devices communicate with each other, sending commands, measurement data, and information about different states. And if one device stops working, only the functionalities associated with it are no longer available. The rest of the installation will continue to function. In addition, a faulty module can be replaced using the same or even another device with similar capabilities. Okay, but where did KNX come from in the first place? Well, at the end of the 1980s, a number of leading electrical engineering companies began talks to develop a unified system for controlling building electrical installations. As a result, the EIB system, whose name stands for European Installation Bus, was established in 1990. The EIB Association, or EIBA for short, was also established. Of course, other manufacturers developed other solutions in parallel, including the Batibus and EHS systems. And so, 9 years later, in 1999, the EIBA formed a partnership with two other building automation bodies using just these two systems. We are talking about the association's Batibus Club International and the European Home System Association. As a result of this merger, the KNX Association was created and its name was changed over time to KNX Association. A new standard was created, which was mainly based on EIB. Initially, it was called KNX EIB, so that over time its name was shortened simply to KNX. Over the years, KNX started to be recognized as a communication standard by standardization organizations such as CENELEC and ISO. SATEL became a member of the KNX Association in 2014. Moreover, in 2019, a KNX laboratory was opened at our company, which was soon accredited by the KNX Association. Our accredited KNX test laboratory joined an elite group of only a dozen such institutions worldwide. Other certification bodies are located in Germany, France, Italy, Spain, Switzerland, and China. SATEL's KNX lab is authorized to test the inoperability and functionality of KNX devices and their firmware or software. A product that passes a number of tests can be labeled with the KNX logo once it has been certified by the KNX Association. It can also be configured in the ETS environment and integrated with other commercially available KNX devices. Well, it's time to say which KNX modules are available in SATEL's product range. We currently have 8 devices that can work with KNX system. This group includes the actuators, the binary input module, and the interface for programming the system, which is also an event recorder. A KNX bus power supply is also available. In addition, a module enabling the integration of alarm systems based on the Integra and Integra Plus control panels with the KNX system is also available. Well, now let's briefly present what each of the mentioned devices offers. The first on our list is the KNX DIM21. It is a universal 2-channel dimming actuator. This device is designed for the smooth control of 230 volts AC powered lighting. Light sources connected to the actuator can be switched on or off, dimmed or brightened. They can also be group managed via a predefined scene or called up temporarily from an external source such as a sensor or button. Each of the two available channels can carry any type of load: resistive, capacitive, or inductive. At the same time, the maximum load power can be up to 300 watts or volt-amperes per channel. Please note that the module automatically detects the type of connected load, R, L, or C, and adjusts the control characteristics accordingly. Now it's time for a pair of twin KNX BSA-12L and KNX BSA-12H blind actuators. With these actuators, we can precisely control the position of various types of curtains, such as roller blinds, awnings, or horizontal and vertical blinds. They will also prove successful in controlling electrically powered curtain rails, windows, or simple motorized valves. Each of these modules has two independent channels. The difference between the two models is that the KNX BSA-12L is designed for 24 volts DC drives, while the KNX BSA-12H will be used for devices with 230 volts AC motors. What distinguishes these modules is the ability to control the blind slats or the height of the curtains very precisely. This solves the problem of blinds or shutters set at different levels in the same room, for example. Interestingly, these modules support weather alarms. This means that you can define how the module will behave and when it receives information from, for example, wind, rain, or temperature sensors, or from a weather station. To what end? Well, for example, when a gusty wind is detected, the awnings can be retracted and the external roller shutters lowered. The second pair of similar modules are the KNX SA41 and KNX SA24 switching actuators. They can take part in the control of various electrical devices, such as lamps, fans, gate operators, or solenoid valves, for example. The modules offer a number of built-in functions, including time or logic, and NAND or NOR XOR. The two actuators differ in the number of outputs. The KNX SA41 has 4 independent circuits, with 1 relay channel per circuit, i.e. 4 relay outputs. The other, on the other hand, has 2 independent circuits, with 4 relays per circuit, a total of 8 relay outputs. Thanks to the separation of the circuits, it is possible to control devices which are supplied from different phases. Each output can be loaded with up to 16 amperes, both for AC up to 250 volts and DC up to 24 volts. Another SATEL KNX module is the Universal Binary Input Module KNX BIN24. The device allows electrical signals, specifically voltage signals from 0 to 30 volts AC or DC, to be converted into control telegrams for other KNX devices. These signals can come from buttons, for example, used to control light. They can also be generated by potential contacts of various sensors of physical quantities, e.g. light intensity or temperature. The module can also receive telegrams from other KNX devices. The device has 4 channel groups: physical, virtual, logic, and timers. The KNX BIN24 has 20 function blocks stimulated from any of the module's channels. These blocks can carry out various control functions, including switch, edge response, dimmer, shutter control, or counter. These blocks can then be linked, tied, or looped together. Another device that, like the previous one, is housed in a DIN rail-mounted housing is the KNX PS640 power supply. It is used to supply the KNX bus with 30 volts DC system voltage, SELV. The maximum output current is 640 milliamperes. Advantages of the device include its high short-circuit input and output resistance and overload resistance. Let's now look at another device. The KNX USB interface allows communication between the KNX bus and a PC with ETS software to program devices connected to the bus. A unique feature of the interface is the ability to work in bus logging mode. What does this give us? Well, it then saves in its memory the history of events generated on the KNX bus. This is extremely useful, for example, when diagnostics are required for the installation of a building. In order to record the movement of KNX telegrams even over a longer period of time, it is not necessary to leave the computer connected to the installation. It is sufficient to leave the interface itself set to logging mode. Here's a note. The device can be powered not only from the KNX bus, but also from the USB port. If, for example, you connect a power bank to the interface, also events of a power failure on the bus or on the 230 volts AC mains will be recorded. The KNX USB soft is used to activate the logging mode as well as to manage the stored data. This collected data can be exported to files in XML format. We can then view them in the ETS program. The data can also be saved in CSV format and imported into other programs. The last module designed to work with the KNX system, although not part of the group referred to as SATEL KNX, is the INT KNX2 integration module. It can be used to integrate KNX devices with intruder alarm systems based on the Integra and Integra Plus family control panels. Signals from the alarm system can be used in the KNX system and vice versa. What does this mean in practice? Well, as a result of integration, users of related installations can, among others, control the functions of the alarm system and building automation system with the KNX devices using a single INT TSI, INT TSH2 or INT TSG2 keypad, or the Integra Control mobile application. Another example could be the motion detectors connected to the control panel, which can be used to control lighting connected to KNX modules. Well, that's all in this episode. Thank you, and see you in the upcoming eAcademy episodes. Until then.